Hello everyone, here we are with our lesson number 3. Alright, so it's the exercise number 2, but that's the third video. So I hope you prepared that exercise 2 that I sent last week and that you have it in front of you and that you read it properly and maybe copied it in your book. Alright, if you didn't copy, you printed it, right? Okay. So that exercise 2, it is a very good summary of everything you have to know for the Unit 11. So it's not everything, but it's the minimum necessary to do the Unit 11 and to understand all those functions. So this table is very important and you must skip it from now up to the final exam of this year. And there is 7 functions that you have to know. So the first one in this paper, in the unit, the first one is the straight line. Okay, this one I hope that you know already nicely how it works. It's always written as a y equal mx plus c, with m being the gradient. So the greater the m value, the faster it grows. So the inclination is higher. And if the number is negative, then the line is declining, going down. And the c is the y-intercept. So, see, if you have a simple multiplication on your x, you have a straight line. That's the first function. Then the second one is the square on the x. The square on the x is a parabola. Which one would be the simplest equation with a square on the x? Well, the simplest one is a y equals x squared. So if you want to add it on that line of the lesson, a simplest parabola is a y equal x squared. Alright, third one. If you have a division by x, you get an hyperbola. So which one would be the simplest function corresponding to an hyperbola? So it's a division by x. So the simplest one would be y equals 1 over x. That's a division by x, and that's the simplest you can get. Alright, number 4. If you have an exponent x, so on any number you have an exponent x, something to the power x, it creates an exponential graph. Which one would be the simplest exponential graph? Unfortunately, it's not going to be 1 exponent x, because 1 exponent x would be always 1. So it can't work for our exponential graph. So the simplest one would be 2 exponent x. This one would be the simplest one. 3 exponent x, 4 exponent x, minus 6 exponent x, all those are exponential graphs. But the simplest one would be 2 to the power of x. Then, third one, we have the sin graph. The sin graph is created by a sin applied on your x. And the simplest one is y equals sin x. That creates a sinus graph. After that, you have the cosinus. This one is a cos applied on the x. So the simplest function with a cos is y equals cos x. And the last one is the tangent. So that's a y equal to tan x. Simplest tangent graph. Alright. But it's not that there is only one graph existing for each function. For a straight line, like you know, you can have the simplest one, y equals x, simplest one, but you can have a 2x plus 3, a minus 6x plus 12, a minus a 4x plus 6. So an infinity of graphs exists for straight lines, because you start from the simplest function and then you build around it. You times it by a 2 and you add a c that can be plus 6. So any other value added on that function will create a different pattern of your graph, but that will still be a straight line. If you have an exponent 2 on your x, you can then start building on it a 2x squared minus 6, It would still be a parabola, but it would be differently shaped, maybe a bit wider, a bit down, shifted. So what makes the shift on your graphs? The most important is the coefficient in front of your graph. So is it a positive graph or a negative graph? If you times by 2, you are in the positive side of your graph. If you time by a -2, you'll be in the negative side of your graphs. And then you have the minus p and the plus q. Those two letters, if you looked carefully, you will have found them everywhere in all the equations of each graphs. Not in the straight line, because the straight line is too simple to need a plus q and a minus p. You only have the plus c. But for all the other graphs after this, you always have a minus p that applies on the x and a plus q at the end of your equation. A minus p on the x and a plus q at the end. Here for the hyperbola, a minus p on the x and a plus q at the end. Same with the exponential, a minus p in the exponent x and a plus q at the end. And you have the same thing for the trig graphs, cosine and tan. Alright, so that means the minus p, you noticed it was always a minus p in the equation. So the minus p was with the x. So that minus p applies on the x value. And what is the x value? The x-axis, so the horizontal axis. So if you minus p or plus p to your graph, you're going to shift your graph to the right or to the left. Let's take a parabola, for instance. I've got that blue parabola. If I minus or plus on the x-axis, I'm going to move right or left. That same parabola. Now, the q is always at the end of your formula. So the q is now going to change the full value of the equation. So it's going to change the y value. So the p applies on the y. And if you change the y value for all the points on your graph, you are shifting your graph on your y-axis, so up and down. So if I take that same parabola here, this one is already, as you can see, shifted down. But if I change the p-value and I make it positive, I'm going to shift that whole graph up. So x is on the x-axis shifted right and left by the p-value. On the y-axis, shifted up or down by the q value. So let's just take, for instance, one example of these graphs, just that you understand exactly what I mean. We said the hyperbola, for instance, the equation of an hyperbola is y equals a. So y equals a over x minus p plus q. All right. So an equation of a parabola can be y equals 2x minus 1 plus 3. Here I've got the minus b equals to minus 1, and I've got the plus b equals to plus 3. If I change one of those values, I'm going to get a new graph, still an hyperbola, still that shape, but shifted. 1 unit right and 3 unit up. So 1 unit right and 3 unit up. I'm going to have now a graph here. Okay, so this is part of the exercise 4. So I just want you to understand that those letters represent values, and those values make one specific graph. All right. So for now, the only thing that you really have to know is be able to recognize what type of graph corresponds to what type of equation. So this is your homework here. So I give you 6 different graphs, And in that block, you must just answer what type of graph. Is it a straight line, an hyperbola, a parabola, a cos graph? And is it the positive version of that graph or the negative one? So that's all what you have to say. Type and positive or negative. Type, positive or negative. So you can check in your lesson, in your table that you have, and you check which one do you have here. And then you send me a picture of this for Tuesday. Alright, that's all for today. So please make sure that you understand this table and that you can recognize the different type of graphs on the positive or on the negative side. And then we go for description of each graph in detail. So ask me any question you have or any doubt that I can help you with, and hope the homework is going to be easy. All right, bye bye.